common factor in the distributive property, and factoring by grouping. But the ultimate goal for today, what you're going to see is as we learn different methods of factoring, factoring is used to help solve quadratic equations. So today we are using factoring to solve equations. So that is the goal. We are solving equations that would be in this form, ax squared plus bx equals 0. So we'll look at how we solve that type of equation. Again, this is the third note sheet of the new chapter, third note sheet that this has been on there. Remembering that factoring, it's the reverse of multiplying. So it's expressing a polynomial as the product of monomials and polynomials. So what multiplies to equal what you're given. When we solve equations by factoring, we use what's called the zero product property. And what this says is if the product, which again, product is what operation? It's what? Multiplication. So if the product of two factors is 0, meaning if two factors multiplied together equals 0, then at least one of the factors must be 0. So think about that. If you multiply two numbers together, the only way to get 0 is if one of those two numbers is 0. Now this says two factors because factors could include variables, but you use that as a way to solve these equations. So the first two examples that are on here, the two examples on the front, it says some equations are already in factored form. They are already factored. Here's how you tell that they're factored. If I look at this equation in number 1, this is 8b times the quantity b minus 5. So this is 8b multiplied by b minus 5. So I have two quantities being multiplied together. The 8b is one factor, the b minus 5 is another factor. So if it's already in factored form and you have the equal 0 on this side, so that's important too, that this side is equal to 0 and not a different number. This is how the zero product property works. This means I would set each factor equal to 0 and solve for b in this case. So again, it says if the product of two factors is 0, at least one of them must be 0. So this means either the factor 8b is equal to 0 or the factor b minus 5 is equal to 0. Okay, so here are my two factors. 8b is a factor, or b minus 5 is a factor. And I set each of them equal to 0. And then I solve those two equations for the variable, in this case b. So how do I solve the first one for b? How do I solve 8b equals 0 for b? What do I do to both sides? Not multiply by 0, Casey. To solve for b, I divide by 8. What is 0 divided by 8? 0. Okay, there's an answer. How do I solve this equation for b? Yep, plus 5, add 5 to both sides. So then I get, because these cancel, I get b is equal to 0 plus 5 is 5. So these are my two answers. B is either equal to 0 or b is equal to 5. So make that connection too. You're solving an equation, meaning you should be getting the variable equals a number. In this case, you will get two answers. So if you're not getting two answers, something's not correct. You should get two answers for these. Okay, questions there? Okay, how could I check these to see if they're correct? Because you can always check your answers to an equation, Casey. Mm-hmm. Yep, you'd have to check them separately. I'm not requiring here that you show me that you checked, but I just want to show you as a reminder that you can check. So if I were to check b equals 0, I plug it back into the original equation. So I would have 8 times 0, and then times, in parentheses, 0 minus 5, and I want to know, does that equal 0? So if I follow order of operations here, start in the parentheses, 0 minus 5, that's negative 5. So I have 8 times 0 times negative 5. What is 8 times 0? 0. What's 0 times negative 5? 0. So I do get 0 equals 0. Okay, and then if I were to check b is equal to 5, so I would have 8 times, put 5 in for b, and then times 5 minus 5. Does that equal 0? Start in the parentheses, 5 minus 5, that's 0. So I have 8 times 5 times 0. What's 8 times 5? 40. What's 40 times 0? 0. So I get 0 equals 0. Okay, so you can check your answers. I'm not requiring here that you show me that you checked it, but you can check it. Okay, just that could even be on the calculator. Plug it into the calculator, type it back in, see does it work out the way that it should. Okay, so let's look at number 2. Now this factored form looks a little bit different than the one we just did. This is more like a GCF factored form. 8b would have been the GCF in front. Here, these are the two factors. So I have 2x plus 6, and then times 4x plus 1. And again, I have my equals 0. You have to make sure this side is 0. Okay, so set up your two equations. So 2x plus 6 could equal 0, or 4x plus 1 could equal 0. Okay, and then you solve these two equations for x. So let's start with the first equation. How would I solve this for x? What would my first step be? Nadia? Subtract 6. So 2x, 0 minus 6 is negative 6. Then next step, divide by 2. So x will equal negative 6 divided by 2. It's negative 3. So there's one answer. In the second equation, what do I do first to solve for x? So 4x equals 0 minus 1 is negative 1. Then what do I do? Divide by 4. So x equals, so negative 1 divided by 4. Nadia? Yes, so either this would have to stay a fraction. It's not negative 4. We're not multiplying. So it's negative 1/4. Or if you put the decimal, which is negative 0.25, that's fine. But these are your answers. This would be alternative, same answer, just as a decimal. Okay, questions there? Okay. Yeah. Are you taking notes? Where's your note sheet? Okay. Still need your attention up here, you guys. Those two examples, the equation was already in factored form. These examples on the back, 3 and 4, are not in factored form. So I have the steps here. This guy's Andrew Michael. I have the steps here for how to solve a quadratic equation up above. This is what a quadratic equation is, ladies. A quadratic equation is in this form, ax squared plus bx plus c equals 0. What makes it quadratic is the highest power on x, or the degree, is 2. You have an x squared. That is a quadratic equation. So when we talk about solving quadratic equations, that's what we're referring to. So to solve these, here is step 1. If this is not already done for you, get the equation equal to 0. So if I look at this equation in number 3, 3n squared equals 6n, I do not have 0 on one side. That's my first step. So to get this side to be 0, I would have to, since this is positive 6n, I have to subtract 6n to move it to the other side. Okay, so this cancels out. Now over here, are these like terms? I see some no's. They are not like terms, so I should not do 3 minus 6 is negative 3. Yep, so 3n squared and then minus 6n is how you'd have to write it. Then I have equals, this side is now 0. Okay, that's step 1. So doing that to get equals 0 is step 1 here. Then step 2, so the way you're going to be factoring these today, because the two methods we know for factoring are factoring out the GCF or factoring by grouping. But with grouping, you need 4 terms. So for today, we're factoring just using the GCF, and this is the left side here. I need to factor this using the GCF. So 3n squared, 6n, what is the GCF? Nadia? 3n, yes. Okay, so I have 3n in front of my parentheses. Excuse me. In the parentheses, sorry. Divide them both by 3n. So what is 3n squared divided by 3n? What is it? N. Or 1n. If you put the 1 there, that's fine. And then minus 2. And then I still have my equals 0. So this was step 2. Okay, you guys, I hear a lot of conversations happening that have nothing to do with what's up here. And when you have work time and you say, I didn't quite understand the notes, it's probably because you're having a separate conversation right now, and that's why you don't understand the notes. And I'm not going to just individually come around and reteach all of you, because right now when I'm trying to teach you, you find it more important to have your own separate conversation. And if you're not taking notes, you guys can use your notes on your assessments. So when we get to an assessment and you say, well, I don't have those notes, it's because you were sitting in class right now not taking them. Okay? You guys think it's funny. It's really not that difficult to just be respectful and take notes and follow along. You're going out of your way to be disrespectful to me and your classmates. After step 2, once you factor it, now this looks exactly like number 1 did on the front, because now it's in factored form. So now step 3 is to set each factor equal to 0 and solve the equation. So one of my factors is 3n, so I'd have 3n equals 0, or my other factor is n minus 2 equals 0. And then you solve both of those for n in this case. Okay, how do I solve this first equation for n? Nadia? What is 0 divided by 3? 0. Okay, that one's done. How do I solve the second equation for n? Nadia? Not a negative 2. Yep. Add 2. So n equals 0 plus 2 is 2. Step 4 is listing the two solutions. Here they are. N equals 0 or n is equal to 2. So this here is step 3. Step 4 is your answer. Okay, those are your 4 steps. Sometimes step 1 might already be done for you. Maybe steps 1 and 2 are already done for you, like they were on the front side. Okay, let's look at example 4. Here's another one. First step, get the equation equal to 0. We have a negative 3x, so add 3x to both sides. So on this side, I have x squared plus 3x. They're not like terms, don't combine them. And then equals 0. Step 1 is done. Step 2, factor this side. So x squared and 3x. What is the GCF? Not 3, because what number is in front of this? A 1. So 1x is the GCF, or just x. They have an x in common, a 1x, that's it. So then I take out the GCF, so 1x. I divide these both by x to get what's in the parentheses. So what is 1x squared divided by 1x? 1x plus, or just x, you don't need the 1 there, 3x divided by 1x. Close. The x's are going to cancel. 3 divided by 1 is just 3. Okay, then it's factored. Step 3, set each factor equal to 0 and solve each equation. 1x is a factor, so 1x equals 0, or 1x plus 3 equals 0. Okay, this equation here, do I need to do anything to solve for x? No, so 1x is just the same as x, so x is 0 is one of our answers. You could divide both sides by 1, you'd still get x equals 0. And then here, what do I need to do? Subtract 3. And again, 1x is just x, so I get x equals 0 minus 3 is negative 3. So x equals 0 or x equals negative 3 for number 4. Okay, those are your 4 steps. Before getting you your assignment, question 5 says which equation is in factored form? 5x squared plus x equals 0 or x times 5x plus 1 equals 0. So which one, equation 1 or equation 2, do you think is in factored form, and then why? Heard a lot from Nadia and Casey today. somebody else, because they're not the only two people in this class. Heard a lot from Riley too. Because you all have to be able to look at this and determine if I'm solving these equations, do I have to do step 2? Is it factored or do I have to factor it? You have to know that. So which one of these would you say is factored, Nick? Equation 2, and why? All right, quiet, please. Yes, Nick? Okay. Yep. Hold on. You three guys right in front here. Are you listening to what Nick is saying? Go on. Gabe. Okay. Or the 1x. Okay, because they divided the x out. Okay. Going along with that, so yes, equation 2 is the one that's factored. So going back to what it means to be factored, it's expressing a polynomial as a product. Here, these two terms are being added together. This is a sum. Here, there is multiplication between the x and the 5x plus 1. That is a product. So which one is factored? But the way Nick explained it is right. The second one, the GCF of x was taken out. The first one, the GCF is not taken out yet. So x times 5x plus 1 equals 0 is in factored form. But I'm going to put as the reasoning because it is written as a product of x times the quantity 5x plus 1. So that's your clue if it's factored, is there a product? So in number 5, that's a sum. There's a plus sign separating them. In the second one, even though the times symbol isn't written there, there's a product between the x and the parentheses. So that GCF is factored out. But being able to recognize if something is factored is important because you need to know whether or not you need to do that step of factoring or if it's already done.